I bought this Canon 5D Mark IV for $500. It was very badly liquid damaged. A while back I made a video about cleaning the liquid damage, but unfortunately it still didn't power on even after it was all clean. So today we're gonna take it apart again and see if we can figure out why it's not powering on. This video is sponsored by JLC PCB, more on them in a minute. In the first video I made on this, a lot of you guys were asking about the battery and whether it was fully charged when I put it in the camera to test it. So we're just going to test this battery right now and make sure that it has a full charge. And we have 7.81 volts on a 7.2 volt battery. And just for clarification, the battery I used on that first video when I tried to power it on for the first time was fully charged. But let's put this battery in and try it again just to see if anything's changed. The fully charged battery is now installed. Let's see what happens. And no surprise there. No power. Now it's time to take it apart and see if we can figure out why. So the battery is down inside the camera and there's battery connections right up here. We can't see them because there's too many cables in the way. But I think after I remove these ribbon cables, I can probe down in there to the wires that come from the battery and see if there's any power on those wires. That'll tell us if the battery connection itself is good or not good. This is also the connector that I replaced in the previous video, so I will go through and double check just to make sure this is all soldered on correctly again. Even though I've already done it, I just want to double check and just make sure that I didn't miss anything the first time. I thought I'd be able to see that battery connector down in there, but I can't see it yet, so I'm gonna remove this main board and see if then I can get up in here and see any of those main battery cables. There we go, that's what we're looking for right there. So this red wire and that black wire, I believe, are main power into this board. So that's gonna be the first thing to check and see if we're even getting power to this board. If there's power to the board, then we know the battery contacts are good. So we have that same fully charged battery installed into the camera. And we have 7.8 volts. So that shows that the power is coming from the battery all the way through these cables and into this little board right here. And then it appears that stuff happens on this board and then power goes from this connector down to the main board. So the next thing we have to figure out is if this board is sending the correct amount of power down to the main board, or if it's just not sending any power at all. So I don't have any schematics or anything like that on this camera, so what I'm gonna do to see if there's power getting to this connector is just test the voltages on each of these pins. So I have my black probe on ground, and I'm just gonna go through and see if there's any voltage getting to this connector. Oh, there we go, 7.78 on that first pin. So that tells me that there is voltage going through this connector. Obviously, I don't know whether those are the correct voltages for each of those pins, but I do know that there is power going through here. So now let's move to the main board and see if we can figure out if there's voltage getting to the main board. So this connector on the main board is a connector that plugs into there. Unfortunately, that's on the bottom side of the board that I'm not really going to be able to test once I have it installed into the camera. Now I could do the work to get this board off and then plug it in over here, but I don't want to do that yet. I want to see if we can determine if there's power getting to the board from this side of the board. Okay, now it's plugged in nice and solid on that connector. I'm going to start testing various points on this board and just see if we have any power at all on the board. So I don't see anything on this board that has any amount of power, so I think I'm going to have to disassemble this enough to get this other little board out right here that comes from the battery cable, so then I can flip this board over and have that board connected, so then we can check the other side of the board. So I might have had my ground probe not hooked up properly. Now that I do, and I checked that by checking another ground point, so I have my meter set on resistance mode, and I will put it on another ground point, and it beeps telling me there is very little resistance between this probe and this probe. Now that I know my grounding point is good, let's check the voltages again. Oh, here we go. We already got voltage on this one. 2.9 volts. 2.9 volts. I don't see anything other than 2.9 volts on any of these connectors, which could be fine. There's just no way for me to know what connectors are supposed to have what voltage. 4.8, okay. That's good. 4.8, and that's the pin that I had to resolder on my last video. So that's good to see that that one seems to be working correctly. Okay, so it's clear that there is voltage to this board. So the next question is why, if this board has voltage, and assuming it has the voltage it should, why will it still not turn on? Before we go any further, I want to take a minute to tell you about JLC PCB. JLC PCB is one of the best places to get your custom PCBs manufactured. They offer fast and accurate service and quick shipping to the United States. You can use their cloud platform for faster and smoother hardware manufacturing. This way you can focus on the design, and JLC PCB handles the fabrication, part sourcing, and PCB assembly. One of the great things about this service is once you upload your design, JLC PCB will look over your design and make sure there aren't any potential problems before it goes into manufacturing. And you can also check the status of your orders in real time. They have over 350,000 parts in stock, and you can even pre-order your parts and have JLC PCB hold them for your order. That way you can ensure that there aren't any last-minute part shortages. They use state-of-the-art production equipment and advanced management systems in order to expedite the PCBA process while maintaining high quality. So if you want to try out JLC PCB service, I'll put a link to a special offer right in the description that'll take you right there. Now let's get back to this camera. This is actually one of the things that I was worried about with this, because if there's power getting to the board, that means that all of these little components, any one of these could be bad and causing a problem. I was hoping that maybe the battery contacts were corroded or something like that, because that would be a pretty easy fix. Once we get down to problems on the board, that's extremely difficult, at least for me, because I have no way of knowing what voltage should be where. If there were schematics available for this board, that would be a different story, but unfortunately there's not. Now with all those ribbon cables back installed, I want to see if there is voltage to this connector right here. This is the connector for the LCD. I'm going to turn the camera on, or what should be on, and let's see what kind of power we get out of this connector. 2.9, 2.8, 2.8. Got a bunch of 3-volt rails. 7.6, okay. So we know there is power to the connector. I feel like there's likely power to turn the LCD on, so let's plug that in next and see what happens. Okay, LCD is plugged in. Fully charged battery is also plugged in. Let's turn it on. Definitely nothing going on there. It looks like there's still a little bit of corrosion on this connector right here. I don't remember whether I actually cleaned this. It is possible that I didn't even clean this last time. So the first step is just gonna be to clean this all up and make sure it's looking good, and then we can plug it in and test it again. So right here you can see exactly what the issue is. We got a lot of corrosion right in here. As far as I can tell, the connection, might be fine. I think the connection might be okay. And then up here, we've also got a lot of cleaning to do here. I'm just getting the main hard stuff out with this pick, and then I'll go through with a toothbrush and some IPA and clean it even better. Looks like those are the main issues. Let's inspect this ribbon cable though too. We need to make sure that the ribbon cable is good as well. Definitely have a good amount of corrosion here. Let's see if the contacts are good. It looks like the traces have not been corroded through all the way. Actually not really corroded at all, just kind of some surface corrosion. So I think we're good there. So we need to do a lot of general cleaning on this. I'm gonna get this part done and then we'll inspect it and make sure it looks good. Now this connector is nice and clean. I did check to make sure there was continuity between this pin and this pad, and there is, so that's nothing to worry about now. I think given the fact that we have this problem with this connector, I'm going to take the rest of this back panel apart and check out the LCD and see if that looks damaged. Definitely had liquid down in here. Well, this isn't the best news. Over here you can see how liquid has gotten all in here and down here. That means that it likely got inside the actual LCD itself. There's also been liquid up here, also some like gravel pieces down here. Even down inside this switch right here, there's also just little pieces of debris down here. A piece of gravel up in here, and also just more gravel down along here as well. Now, one thing that I do want to mention is I have had people wonder why this camera wasn't sealed up better. And my understanding is it's not a matter of the camera being sealed up. I think what the seller said was that either the lens was off of the camera or something similar like that, so water was easily able to go in, right where the lens cap would be or the lens would be. So I think the camera itself is sealed up pretty well, but if there's no lens or lens cap on, then water can very easily get inside the camera. Yeah, and there's little gravel pieces right up in here too, just like everywhere in here. Now with all that cleaned up, I'm gonna get this whole assembly back together. Then we'll put it back on the camera and just see if it happens to work. I'm pretty sure it's not gonna, but hey, we might as well try. Now that we have everything put back together for this rear panel and LCD, let's plug it back in, see what it does when we try and turn it on. Okay, just for the record, I don't think this is gonna work, but let's see what happens. And just nothing at all. So unfortunately, once again, this camera wins. I'm gonna officially call this camera not fixable, and I won't be making any more videos about this one, but if you wanna see me try and fix another high-end camera, let me know in the comment section and maybe I can find another one to buy to make another video about. If you haven't seen the first video I made on this camera, I'll put a link up on your screen now so you can come hang out with me over there and see all the things I did to try and get it to work in the first video. Thank you to JLC PCB for sponsoring this video. I'll put a link to them right in the description that'll take you right there. Thank you so much for watching today, and I hope you have a good one.